Okay, now let's look at interest that is compounded a certain number of times a year or compounded continuously. Now you can take the time to read all this. It's just kind of a formal academic wording here, but really you just need this and this. And so I'm going to take this and explain to you what each of those variables are, which aren't too different from this one. The only difference between this one and this one is this one has an E, and this one has an RT, and this one has an NT. So let me explain these, and then we'll look at an example problem. A is your dollar amount, or your amount after interest is added. So let's say added here. And then the P is your principal. The principal is whatever your dollar amount was before interest. And then you have R, which is your rate. It's normally given to you as a percent in the problem. Make sure you make it into a decimal in order to plug it into this formula. This should be a decimal, not a percent. Okay, and then N, which is written twice right here. We need the N twice. This is the number of times your dollar amount, your principal is compounded. Now, when your principal is compounded, that is when the interest is added to it. So how many times a year the interest gets added to it. And then the last variable right here, the T, is the number of years. And all these numbers or variables A, P, R, and T are the same on the continuous function. So let's take a look at an example here. We're going to look at this problem. It says $12,000 is invested at an annual interest rate of 9%. Find the balance after 5 years if it is compounded quarterly, monthly, and continuously. Now, quarterly, if you were to take a guess, if something's compounded quarterly, there's 4 quarters in a dollar, so that means it's going to be compounded 4 times a year for the 5 years. And so what you would do is you would use A equals, and then your principal before the balance has the interest added to it is 12,000, and then you have the rate. You want to multiply it times 1 plus the rate, which is 0.09 over 4, because it's compounded quarterly. That's where we get the 4 from. 0.09 is your 9%. And then we're raising that to 4 times 5. Again, 4 is the number of times it's compounded, and 5, that's how many years. Alright, so let me plug that to my calculator. When I plug it into my calculator, you want to do this stuff first. Multiply it by 12,000 last. So, because I know 4 times 5 really fast, I'm just going to write 20 right there to kind of simplify what I have to put into my calculator. But do this first and then raise it to that power. Okay, when I raise it to that power, I get 1.56051. Actually, we only need 3 decimal places, but since the third decimal place would be a 1. And then, actually, I don't clear it from my calculator, but since I'm writing it out, I'll just round it to 3 places. But normally, since it's already in your calculator, don't clear it. Just press Enter to get your answer, and then go times 12,000. And when I multiply times 12,000, the dollar amount I get is 18,726.10. So that's our dollar amount if it's compounded quarterly. Now let's do monthly. Monthly is almost exactly the same thing, except it's not being compounded 4 times a year. Instead, there's 12 months. So we write 12. There's 12 months in a year. That's how many times it's compounded. So we're going to put 12 times 5 right there, which is 60. And then let's go ahead and plug that into our calculators. And so I'm going to do 1 plus, and I put parentheses, 0.09 divided by 12, close parentheses. I press enter. I get 1.008. Now I'm rounding it right there, but in your calculator just leave it and then say raise that to the 60 power. Now when you use when you raise to a power, you're looking for this button, the caret button, or you're looking for this button. One of these buttons will allow you to enter a power. And so after I enter the power, I get 1.56568, and then I'm going to multiply that times 12,000. And I get 18,788.20 cents. So that's our amount for when it's compounded monthly. Now let's do the continuous. And the difference with the continuous, I'm going to clear everything here. The difference with the continuous is you use a different formula. This one is A PERT. A equals principal times rate, times the natural base raised to the rate times t. So we have the principal, which is 12,000, times E raised to 0.09 times t, which is 5 years. And so let's go ahead and do this first if you can't, like if you have to enter in the exponent first. But I don't have to enter the exponent first, so I'm going to do it on my calculator. I go E raised to the 0.09 times 5, close parenthesis, I get 1.568, and I multiply that times 12,000, and the dollar amount I get is $18,819.70.